Okay, so we're going to finish up 4-2 today. So we yesterday talked about quadratic formula, and we did a couple more examples using completing the square. So the last part that we have left is talking about how we use part of the quadratic formula to tell us what types of roots we have, so we don't have to work it all the way out before you say 2 real roots, 1 real root, whatever. So we're going to talk about that today. So as the video showed us yesterday, this is the quadratic formula, correct? Okay. The part of this formula that is important to finding the number of roots is what's under the radical. What's under the radical? And we call this the discriminant. The discriminant. B squared minus 4ac is our discriminant. And the discriminant tells us what type of zeros our function has. So again, the discriminant tells us what types of zeros our function is going to have. And we're going to talk about a quick rule that tells us that. So there are 3 cases with our discriminant. So again, the discriminant is b squared minus 4ac. Okay? Our first rule, the first case is that our discriminant is positive. Positive. That means we have 2 real roots. Okay? And those real roots are going to be different. Okay? So if you want, in your book, they call this distinct. 2 distinct real roots. So 2 separate answers. And if you look at that, that hopefully should make some sense. If this is a positive number, okay, no matter what it is when I take the square root, it's still going to be a positive number, right? So if I take negative b and I add a positive number, and then I take negative b and subtract a positive number, those will be different. Will they not? Okay? So that's where I'm getting, you will always have 2 real number answers if your discriminant is positive. Okay? The second case, well, what happens if my discriminant equals 0? If my discriminant equals 0, well, if we look at that, what's the square root of 0? 0. And then if I add or subtract 0, what am I going to get? Well, 2 negative b, I'm sorry. So if I take negative b plus 0, I get negative b. Yeah? If I take negative b minus 0, I still get negative b. So how many different answers am I going to get if my discriminant is 0? Just 1. Okay? So if the discriminant equals 0, we have exactly 1 real root. And we call that a double root. And the reason we call it a double root is I get the same answer twice. Because again, a quadratic always has to have 2 answers. Well, if I get the same answer twice, I have to show in some way that I still have 2 answers. They just both happen to be the same. So we put a little, and how we label this most of the time is dr after my answer. So let's say I get x equals 2, and then I also get x equals 2 again. You can either write it like that, or just say x equals 2 d dot r. And that means double root. And again, that just simply means I'm getting the same answer twice. Okay? If you prefer to just write it out, that's totally fine by me as well. So we have discriminants positive, we have discriminant equals 0. What's the only case we have left? It's negative. So if my discriminant is negative, that means what's underneath my square root is negative. What type of roots am I going to have? Imaginary, complex, right? So if my discriminant is negative, that tells me I have two complex roots. And what does it mean by complex again? They have an I in the answer. So another way of writing that, if the question asks, how many real roots do you have? Well, if they're both complex, that means you have no real roots. So those problems in 4.1 that ask you to say how many complex roots do you have, if it was a quadratic, you could have just done b squared minus 4ac instead of having to work it out all the way. And that would have answered the question. So this is a pretty handy tool when it comes to doing quadratics. And it's also a good way to check your answer to make sure that the answers you got matches what your discriminant says you should get. Questions so far? No? Okay. Let's do an example so you can actually see how this works. Find the discriminant of x squared minus 4x plus 15 equals 0, and describe the nature of its roots. Then solve the equation by the quadratic formula. So find the discriminant, describe the nature of its roots. So we have to first find that and see, okay, am I going to have real, two real, one real, or two imaginary roots or complex roots? And then we have to solve using the quadratic formula. So first thing we have to do is make sure my equation is in the right standard form. Is it in quadratic standard form? Yes. Okay. What's my A? 1. What's my B? -4. What's my C? 15. Okay. What? Okay, so we have that. What's the equation for the discriminant again? B squared minus 4ac. So I have -4 squared minus 4 times 1 times 15. Well, what is -4 squared? Positive 16. 4 times 1 times 15 is 60. 16 minus 60 is -44. So that tells me I have two complex, bless you, roots. So we found the discriminant. The discriminant value is right there, -44. We described its nature of its roots, two complex roots. So what do I have left to do? Solve the equation by the quadratic formula, yeah? Bless. Now, bless. The nice thing about this now
we solve the whole thing.
Now we solve the whole thing. The nice thing about this now, though, is we've already done b squared minus 4ac. Have we not? Yeah. So, all I got to do now is plug in the rest and work from there. So, opposite of b, that's +4, plus and minus, the square root of, well, we already said b squared minus 4ac was negative 44, right?
Yep. Just 2 times 1.
And the bottom is just 2 times 1. Everybody with me as to how I got those?
Yeah.
Okay?
With the cake, 44.
We do. So now I got to simplify 44. Well, first thing, it's negative. So what do I need to pull out? I. Square root of negative 1, which is I. Now we need to try and kick 44. What goes into 44?
2.
2 and 22.
2.
2 and 11. And 11 is prime, so 11 and 1. And again, it's a square root, so I'm looking for pairs of
So like I
2.
2i squared.
So I've got 2 square roots of 11 there. And then that's all over 2.
Wait, what about the A? No, never mind. No question.
2 times 1. Say what?
Can we simplify more?
No question.
Can we simplify more?
Yes. Now, look at all the numbers up front, all of our constants. 4, 2, and then 2 on the bottom. They're all divisible by 2. So this simplifies to 2 plus and minus I square roots of 11. 4 divided by 2 is 2. 2 divided by 2 is 1. You can only do that if both A and B and the number on the bottom are all divisible by the same number. Otherwise, you just leave it alone. So this is x. So what's this tell us? Does my graph ever cross the x-axis? No, it does not. No, it does not. Does this concept make sense, or do we need another one?
It's
good?
Pretty good sense.
Okay. All right. Last thing I want to make sure we remember. And we've talked a lot about this already. I just want to make sure we remember what that is. So, what is a conjugate? But they're just opposite, right? So, if we're talking about a complex conjugate, if I have A plus BI, its conjugate is A minus BI. Okay? And when you FOIL conjugates, what do you have to do? You only have to do first and last, right? Only have to do first and last when you're FOILing. So if I give you 4 plus 2i, and I want to know what's the conjugate of that, it would be what? 4 minus 2. Good. Okay? One more here. If I give you negative 1 plus the square root of 11i, what is that conjugate? Good. Negative 1 minus the square root of 11i. Do not change the number out front. If A is negative, you leave A negative. The only sign you change is the sign in the middle. Okay? Everybody good with that?
Mm-hmm.
All right. All right, so I'm going to give you your homework, and then I'm going to let you work. Yep. So it's going to be on Schoology again. Hopefully you downloaded the chapter last time, so you don't have to keep opening it.
That's the one.
So there's your 4-2 homework. 12 through 14, 16, 20, 23, 27, 28, 32, and 34.